Hello everyone, and welcome to this video titled Words that Describe Mathematical Operations. In this video, I'm going to be going through some of the adaptive practice problems in CK12.org's Algebra 1 text. So here we are in the adaptive practice titled Words that Describe Mathematical Operations. Now I will be going through just 5 of the 10 of these initial exercises here in this video. I would highly recommend that you check out ck12.org, their Algebra 1 text yourself, and you can practice to your heart's content. Even after you've finished all 10, you can continue practicing afterwards. All right. And I would highly recommend that whenever I start a new exercise or a new example, pause the video and try to see if you can work it out yourself first, before you watch me do it. Okay. So in this first example, we're asked to write an expression to describe the situation. A car travels 50 miles per hour for a certain number of hours. And that's it. All right, so I'll pull up the scratch pad here, do some writing. So what we have here is, this car travels, car goes, 50 miles per hour. Now, whenever you see per, that implies division is happening. It's a ratio, 50 miles per hour. And this is happening for an unknown number of hours, right? They said for a number of hours. Okay. So whenever you're reading through a word problem or some statement that you're asked to translate into mathematics, look for the quantities that are unknown to you, like this here, a number of hours. So I've noticed in the selections for the answers with multiple choice, they have the letters H or T in there. I'll let H be the number of hours the car travels. Right. So you'll identify your unknown quantities, what's unknown to you, and call it something. Assign that unknown quantity a variable or some full expression. It doesn't have to be a single letter, but most often it will be a single letter. Now they're asking us to write an expression for the distance traveled. Right? The car travels 50 miles an hour for a certain number of hours, so like you're pretty much going to be concerned with how far the car has traveled. So something they're kind of assuming you know how to figure here is that distance equals rate times time. Right? The distance traveled, which I'm calling d here, is equal to the rate of speed, right? How fast you're going, multiplied by how long you've traveled for. So in this particular instance, right, the rate of speed is this 50 miles per hour. Okay, that's going to substitute rate. And the units for time is in hours, and that's what I have for h over here, right? The units are in hours, and that'll be my time, the number of hours. So when all is said and done, when I'm thinking about this scenario, the distance traveled is, 50 miles per hour multiplied by the h hours traveled. And then you would have unit cancellation. If I take miles per hour and multiply it by quantity with hours, the hours would cancel and you'd be left with miles, right? The final units here would be miles, but this is all they want. You just write an expression to indicate, the situation being described. So 50 times h or 50 times t, I would choose answer D here, and then let's check it out. Wonderful. Identify unknown quantities, call them something, and then certain key words. Miles per hour means you have a ratio per division going on there, miles over hours. And then to get a total distance, you have to multiply speed by time so that the time units will cancel and you'll be left with distance units. All right, let's keep going. All right, so here's another little couple sentences word problem here. So Mike had $100. His money is increased by $25 after his tutoring job. How much money does he have now? All right, so once again, this is about words that describe operations. When I saw miles per hour in the last one, that implied division, and to cancel the hours units, I would have to multiply, right? Here, the key word is increased by. So they said Mike had $100 and it was increased by the $25 after the tutoring job. The words increased by imply addition, the operation of addition. So the amount of money that Mike has after the tutoring job is going to be 100 plus 25 or $125. Right, so hopefully that was a simple enough one. That's all we're being asked to determine there. So that would also be answer D. Check it out. Wonderful. Yeah, increased by would be adding. Decreased by, right? If you had the words decreased by, that would imply you're subtracting. Next example. All right, so now we just simply have an expression given to us already. 5v or 5 times v, right? When a number and a variable are touching like this, it's implied to be multiplication. And we're asked to evaluate, right? So find the value of, find a number. The following expression if v equals -3, right? So I'm just replacing v in this expression with -3 and evaluating, finding the value of. So like I said, we have 5 times v, but v, they're telling us, is equivalent to -3. So I'm making this substitution. All right, so this expression now has this value, 5 times, and then I like to do this. I would recommend that you do this as well. Every time you make a substitution, put parentheses around what you're substituting. So I'm putting parentheses around, this number, -3. Just, it'll help you out in many, many situations. It's not always necessary, but here, because v is being multiplied by something other than 1, I'm going to do this thing with the parentheses. Really, the parentheses are going to be necessary if what you're substituting for is multiplied by something other than 1, or raised to a power that's not 1, raised to an exponent that's not 1. Those would be really, or being subtract, like I said, anytime you have a coefficient that's not 1, or a power, an exponent that's not 1, it would be beneficial to put parentheses around what you replace. All right, and then we have a simple multiplication here, right? Remember, a positive number multiplied by a negative number is a negative number, and 5 times 3 is 15. So this is it. This is the single number that this expression has a value of when the value of v is -3. And that's all I'm entering here, right? Negative, right, minus 15. And then we'll check it out. Wonderful. All right, next example. All right, so one more. Evaluation of an expression. So evaluate the following expression when t equals -5.9, and the expression is -3p, or -3 times p multiplied by t, and t is -5.9. So I'll write the same thing as like the last question, -3 times t. The value of t is -5.9, which, if you want, you could also express this as a fraction, 59 tenths, right? Because this is ending in the tenths place, 5.9. That spot is the tenth place, so you just do the digits 59 divided by 10. Same thing as 5.9. All right. So now I make the substitution. We're going to take this value of -5.9, or -59 tenths, and substitute it for t. Right, so now this expression has this value. So -3 times, and then I'm going to put parentheses around what I replace because the coefficient's not 1. And do -59. I like working with fractions more than decimals myself. So -59 tenths or -5.9, same thing. Now you could also think of -3 as -3/1, right? Anytime there's not a denominator, you can think of the denominator being 1, -3 divided by 1. All right, and then when you multiply fractions, right, you multiply the numerators, multiply the denominators, and then simplify if necessary afterwards. So I'm going to multiply these numerators. Now it's -3 times -59. So that's positive. 3 times 50 is 150. 3 times 9 is 27. And then add those up, 177. Right? And the numerator, positive, right? Negative times negative. This will be a positive number when we're done. And then the denominator is 1 times 10, which is just 10. And then if they want the decimal again, because their initial input was a decimal number, remember 177 divided by 10 is 177, where the number ends in the tenths place. So my decimal point would be here, so that the number is ending in the tenths place. And there we go. Right, this should be the value of the expression that they want. Right, 17.7. Let me go back up here and enter that and check it out. Wonderful. All right, so we've had a couple problems where we had to see the multiplication or division happening. And we had and where we had to see increase or decrease, right, adding or subtracting happening. We've seen these last two, where we were just making a simple substitution and multiplying. Now let's see what this last question I'm going to do. Like I said, I'll just do 5 of these. Let's see what this last question holds for us. All right, so it's just one more evaluation of an expression. All right, so let's do that again. We have -4.5 or -45 tenths, right? That ends in the tenths place, times b, and the value of b is -4. And then what's the value of this? Okay. So negative 4.5 times b, and the value of b is negative 4. So once again, I'm making this substitution. All right, now I remember I said I personally, you do not have to do this, but I like working with fractions over decimals for some reason. I don't know, maybe I'm a little weird like that, but so this negative 4.5, I'm going to rethink of as negative 45 tenths. All right, negative 45 tenths multiplied by, and then b is negative 4, right? So I'm replacing b with negative 4. That'd be negative 4 over 1, right? If I think about it as a fraction with if there's no denominator, it's a denominator of 1. And then I'll multiply my fractions here. Now in the numerator, this is a negative number multiplied by a negative number. So the result will be positive. In the numerator, 4 times 45, really, because again, negative times negative will be positive. So really what I have here is just 4 times 45 in the numerator. 4 times 40 is 160. 4 times 5, 20. You add those up. We'll make 180 in the numerator. And in the denominators, 10 times 1, 10. And 180 divided by 10 is 18, or 18.0. But if you have a 0 at the last spot, that's not significant, right? So we don't need to write it. This is just 18 is the final value they are asking for. We enter that and check it out. And wonderful. Okay. All right. So hopefully this is helping you out a little bit with evaluating some simple expressions, for certain when you're plugging in values or substituting values for a variable. Saw a few of those. But also keep in mind that you might come across word problems like in the first two examples. And I didn't cover a lot of that here. I didn't have a lot of different varied problems, but keep some key words in mind. Maybe when you're doing the reading through the text, the Algebra 1 text at ck12.org, they'll highlight some key words or phrases to look out for when translating to mathematics. Increased is your addition, decreased, fraction. Very often the word of means multiplication. What's 20% of 10? You're multiplying there. I mentioned per, right? Miles per hour. That implies there's a ratio or division of things with certain units. Less than, greater than. Like there's lots of words out there that I can't get into all of them. That you need to read up on, and hopefully with enough practice you can more easily translate English phrases and words into mathematics. So again, I hope this helps you out a bit as a start. Keep practicing on your own, right? Fill it up, finish up the bar here, continue on for more practice afterwards, right? Do the readings, take notes, whatever, watch videos, do all sorts of things to keep practicing. And thank you very much for watching.